that's really, really something that is special, I think, for ACI. It's not a vacuum. It's not just only academics. It's not only industry. That in some conferences like that, right? It's just only industry, and we are just a few academics there. That also doesn't work so well. But this one has the perfect mix, and I really think that's something special.
Hi, folks. Welcome to this month's episode of Engineering Greatness. This is an original podcast series produced by the American Concrete Institute, ACI. My name is Pranoy Siraneni. I'm an assistant professor at the University of Miami in Miami, Florida. And I'm really very happy today to co-host this podcast with Professor Miriam Bilili-Zancos. Miriam.
Hi, I am Miriam Bilili-Zancos, and I'm assistant professor at Purdue University Civil Engineering here in West Lafayette, Indiana.
It's really funny because I think we've exchanged a few emails, we've done some similar things, but we've actually not met. So maybe at this ACI we'll meet. Let's see.
For sure. I will looking forward for that.
All right. So do you kind of want to talk about why you started doing civil engineering or your educational journey, let's say?
Yeah. Well, I was a first generation college student, and I grew up in a very small town. So when I was a kid, I had no idea what really was civil engineering. But my uncle was a carpenter and has just the carpentry next to my house. So I used to, like a kid, I used to go there and build all kind of structures just for fun. And that really, I think, woke up my interest for building things. And then I was, very curious kid. Like I like to, well, I asked for my birthday for a very little microscope, and I used to play to be a scientist and mix of kind of things like soil with cleaning products, with things that, by the way, if there's any kid listening to this, don't do it. It is dangerous, but but I did, and it was a way for me to kind of dreaming to be a scientist one day. And then when I was already in high school, one professor told me, you love math, you love physics, you love helping people, and you really like also construction. So I think your path is civil engineering. So then I was looking at that, so like, yeah. And that's how I enter civil engineering program in my home country, which was Spain, in the University of La Coruña. How about you?
Yeah. So before I get to that, actually, just curious. So you said, so where in Spain are you from?
I am from a small town. The name is Finisterre, which means the end of the world. And there is it's northwest of Spain. It was a very little town. Most part of the people are just fishermen and I really like the places. It's beautiful.
So I always make the joke that I come from a small town in India, and it's a joke because the city I come from in India is about 10 million people or something.
Wow.
So and in India, I'm not saying it's not a small town by any stretch. It's one of the larger cities, but it's not the largest city either. So anyway, I come from India, from this place called Hyderabad. And in general, since I was young, I always wanted to be an engineer. I always kind of liked either making things or breaking them. And like you, I was also very interested and curious. And I always like to ask why. And that's true even now. And that's what I tell my students as well. It's always very interesting to ask why. How and what are interesting, but for me, why is a lot more of interest. So in when I was finishing my high school, etc., we a lot of Indians ultimately do become engineers. It's a very popular profession. I don't think civil engineering was anything. It wasn't like, for me, it was civil engineering or nothing else. I was very interested in civil engineering, but at the same time, I think I would have been very happy if I got mechanical engineering, right? Because that's also something that I was very interested in. But ultimately, we had to go through this engineering exam for Indian Institute of Technology, so something like that. And the thing that worked out the best was civil engineering. So that's what I took. But at that point in time, I can tell you that even if it was another branch of engineering, I probably would not have minded. And then specifically with respect to concrete, it's interesting because as everyone knows, civil engineering is very broad. We talk about structures, we talk about materials, we talk about geotechnical, we talk about transportation. And I really think the main reason I'm doing concrete is because of the professors who taught concrete. They were absolutely fantastic. And they really were very passionate about the material. And when people are passionate about something, I think it rubs off on students as well. So I saw this and I was like, yeah, I think I really like concrete. And I also like concrete because it is a fascinating, interesting, complicated material. So that's how I kind of started. And it's also interesting because I think to a certain extent, a lot of me going on this path is simply maybe a little bit of accident or a little bit of I didn't have any other option. So what happened after that is, so I finished my undergrad in 2008. So at that point in time, I knew for sure I wanted to get a master's because I really did want to study a little bit more about concrete, etc. I applied to Purdue, by the way. And actually, I think I did get an offer from Purdue. So this was long ago, relatively long ago, when masters used to be funded. Now I think it's very difficult to get funding for your masters, but at that point in time, it was possible. And it was easier for me to do a master's with funding rather than without. The US is pretty expensive. So ultimately, I went to Illinois, which is not that far away from Purdue. So there I worked with Professor Leslie Struble, who's now retired, and Professor John Popovich, who is still around and is active. So then I did a little bit of work, and I was completely sure I would never ever do a PhD. But these things they don't actually work out the way you want. And also it was funny because I was in Illinois from 2008 to 2011. This was around the time of the recession. I think at least on the East and West Coast by 2009 or 10, things were a lot better. I don't think they were that good in Illinois even then. So I looked and looked and looked, but I could not find any job. So the only thing I found was a PhD. So then I decided, okay, you know what? I'm going to do a PhD. And this was at ETH Zurich, so in Switzerland. And then kind of the same thing happened where I was finishing my PhD and I was 100% sure, oh my God, I do not want to do a postdoc. I do not want to be a professor. Let me get a nice job. That also did not work out for whatever reason. So I got a postdoc at Oregon State. So this was in 2015, working with Jason Weiss, who used to be at Purdue, right? Yeah, so I mean, he just left Purdue at that time. So then I did a postdoc for 2 years. Again, I was absolutely sure I would not become a professor, but clearly I'm very bad at planning, so I should not do it. But anyway, so things worked out or they didn't work out. I don't know, but I've been assistant professor at UM for about 6 years.
At least for concrete, the industry really work out. We're very happy. We have, so things for some reason happen, and I think in this case it was a blessing for us. So even that was not your plan, it's not a bad thing. It was a very good thing, at least for our community.
I mean, I'm sorry, I'll let you tell your part of the story, but I mean, even though none of these choices were choices that I made, I've loved every one of them, right? I mean, every one of them, I've had a really, really great time. I've really enjoyed doing what I'm doing. So
yeah, no, I mean, I am sure. I mean, so your work is clear. You like it. So in my case, the way that I got into concrete was first because I really wanted to be a researcher. And when I was doing my my undergrad, I had the opportunity to start doing undergraduate research. That was in concrete, in particularly related to non-destructive testing, even though then I end up doing more other things. But that was a really game changer for me, because if not, I don't think I will find a path to go for research. I really wanted, but I didn't know even how to get into there. And that was amazing. And that's one of the reasons why I really like, undergraduate research. And I have many undergraduate researchers in my class, in my research group, because I really think it can be a game changer for many. At least, you explore this area and then you decide. And in my case, it really worked out. So even before I finished my undergrad, my advisor at the time, Isabel Martinez, called me one day. I remember I was in a gas station and she called me to my phone and said, like, Miriam, we got a project. You have to start right now. So like, I didn't finish the undergrad. So like, I don't care. You just start now. It will take a little bit more time, no worries. But if you really want to do it, we have a project. I say, like, what is the project about? And she says, about recycle concrete, aggregating concrete. I say, yes, then yes. So I went for it, and that was a great journey. So my research then it was more related to sustainability, and that's something that it really gets me. And that's it. In fact, right now I do also sustainability on concrete in different areas, not in that one only, in other ones. But the reason is because we know that concrete is the most used construction material in the world. So if we can make it more sustainable, we make a huge impact. And that's why I was like so passionate about it. And then I was able to get a postdoc and then faculty position, and now I'm here. So I really think it was, what I did was kind of take any small opportunity I have to be able to get into the point that I have my microscope right now, and it works. So it's kind of the situation right now. So that was my path started with undergraduate research.
I did a little bit of undergraduate research as well in again on concrete. And actually, it was interesting because at that time, we had to do a thesis. I mean, it's not quite a thesis. I see that kind of going away right now. But I really enjoyed spending almost a year doing. Okay, I was an undergrad and I didn't know, a lot of details about concrete, etc. But I had a lot of time to actually work on it, and it's a little sad to me that right now, as undergrads, at least in engineering, you don't get a lot of time to do research. And what I'm seeing is the same thing is happening in masters as well, where a lot of our masters are becoming 1 or 1.5 years. So there just isn't a lot of time to do research. They still do research. It's just that it's a small amount of research. It's not that.
Yeah, well, it depends a little bit of the program. We have, for master, we have two programs. One is 1.5 years and is professionals master, but then we have the one that is research based, and they have to go and do the full thesis. And that one is funded. We pay for that, and then they do research. But it's true that because also there's a lot of different courses and things around. It's kind of packed. It's difficult. But for undergraduate research, I really think we should do more, because that can be a path for us to find, the leaders of our industry in the future. And there are some initiatives, but I think they are not enough. As I said, some of my master's students and even one PhD student was my undergraduate researcher before, and that really helps, because you can kind of really help the student to go through the process, and when they get to the PhD, they really know already many things.
Same. I completely agree with you. So I don't have a lot of undergraduate students working with me. Again, I think, we are a smaller university. We are not Purdue. But I really enjoy working with the undergrads. And one of the things I actually really like to do is to hire kind of a somewhat diverse set of undergrads, in the sense that I really try my best to not hire undergrads who are simply civil engineers or doing concrete. There's nothing wrong with that. But I find that some of my undergrads have been anthropology. Some of them have been marine science. One is a sculptor. right? So I think by kind of hiring these diverse undergrads, I think it really helps because they have a lot of skills, for example, that civil engineers don't necessarily have. But then later on, if they decide, you know what, I like concrete, this is what I'm going to do, then that's a fantastic win as well. So
Yeah, I agree, because they have different views, and that really helps to solve complex problems, right? We really need to open our mind and see different backgrounds, different expertises, and that really helps to just make something transformative. So I 100% agree with what you are saying.
so tell me a little bit about your current research or your research interests more broadly.
Yeah, well, I do research mainly on CO2 capture, on sustainable concrete in different aspects. We can make concrete more sustainable, making it more durable. We can make concrete more sustainable, optimizing the resources to have a lower carbon footprint. Also related to recycled concrete aggregate, I have a lot of research on that area, and then making concrete to work for us. For example, photocatalytic concrete or concrete that can clean itself. What I always call it proactive materials, right? It's not only concrete, it can be also different coatings, or there are even, in some cases, other materials, cementitious composites in general. But these are kind of what I am doing, is trying to make concrete more sustainable with different perspectives. And then, of course, doing life cycle assessment from a holistic point of view to just really check if is this really sustainable or not, because it's not as obvious. You really need to run the numbers and see, okay, this is sustainable because it lowers this and that, or not. And that's I think a very interesting journey, because also I have a group with several PhD students, masters, so each of them specialize on one of these areas, and that's the situation right now. How about you?
So I've actually read some of your papers on nano TiO2. It's been a while. I don't remember everything, but yeah, those were very interesting.
Oh, thank you.
I think I think they were with Carlos Moro. I think
Yeah,
it's
that's the
it's
one.
been, yeah.
Yeah, that's one of my PhD students. Well, now he already graduated. He's now a professor himself.
Texas State, I
Uh,
think.
yes.
Yeah.
A program that is
Congratulations.
really on concrete. Thank you so much. Yeah, that's another thing that I really like about our work, like working with the students, help them to go through, not entering the lab when they arrive. They never enter in a lab, and suddenly in 3-4 years they are professors. This is kind of a really big transformation. That's what happened with Carlos, also with Dan Juan, who's another of my students that already graduate. She's now starting a tenure track position. So I really like that part. Like, it's not only the impact that we can do with our research, it's also the impact that they will do after that. So whenever we retire, that it will be a long time ago, long times from now. Still there will be someone that keep doing an impact, even if we are already in Florida or something.
You can say that we are engineering greatness. I'm just kidding.
No, kind of. I mean, it's I think it's really true. Thank you for the comment. I mean, I'm very proud of my students, because they are doing great.
Yeah, that's fantastic. So, in terms of my research, broadly, there are two different things that we do. The first is research on supplementary cementitious materials, concrete durability, that sort of stuff. And the second is looking a little bit more at coastal infrastructure, which is maybe not a surprise given that we are in Miami. So on the first topic, I'm primarily interested in two things. One is processing. So this includes grinding materials, or thermo processing of materials, but basically various processing structure property relationships of uh, manufactured SCMs or other topics, where we make a whole bunch of changes and we kind of try to see what happens. I'm primarily interested in model systems. So we make some synthetic calcium aluminosilicate glasses. That's a major area of interest. Reactivity is another major area of interest. With Jason, we developed several different reactivity tests that we continue to employ on supplementary cementitious materials for rapid screening of reactivity. Then I'm also interested in CO2. And here we're interested in a range of different materials. We're interested in CO2 uptake of powders, so just, fillers or supplementary cementitious materials, going all the way to blocks. And this is interesting because, of course, at the small scale in very homogeneous, or at least at some scale, homogeneous materials, it's a lot easier to understand the microstructural modifications that happen versus something like blocks, where sometimes it's not even easy to measure the CO2 uptake just because of how heterogeneous they are, or because the values are simply so low. So a whole bunch of topics related to SCMs, model systems, CO2 uptake, durability, etc. And the second topic is coastal infrastructure. So we are interested in developing concrete for artificial coral reefs. We are interested in looking at the next generation of seawalls. We are also doing some work on understanding how we can make corals more resilient, things like that. This is not something I'm an expert on. It's something that I'm really trying to learn, starting to learn, etc. The University of Miami has a fantastic marine school. We have several different projects on this. So it's an active area of research, but I'm absolutely not an expert on this. So maybe in 5 years, I tell people I'm an expert on this.
I mean, that's a very exciting topics, and in fact, in this last one, I am not also an expert, but we should talk maybe after the podcast. We also are doing something with the University of Puerto Rico on that, so maybe we can collaborate. I will show you later some information, but it's also kind of recent, but very, very interesting topics. And the treatment of different materials with CO2, that's a topic that I think is massively important. So yeah, that's very exciting.
Yeah, I always say, I'm working on CO2, but almost everyone is right now. I mean, you kind of have to, also because I mean, there is millions, if not billions of dollars in things like this, because this is the future.
Yeah, no, and it's important. I mean, we can do waste valorization with CO2. We can do many things. Yeah. And there's a lot of variety of things that we need to walk until getting to the real impact. And for example, with the way that measures the CO2 uptake, we just develop a method to direct measure that, because the other methods, as you said, it's very hard to say. So now we get one that I think, at least for comparison, different materials and which one uptakes more CO2. That's
we should definitely talk a little after the meeting if you have some time. I also want to tell you about the NIST low carbon cement and concrete consortium, in case you're not aware, but a few things maybe.
Yeah, that would be great. We have to have a meeting for sure soon, because I think there's a lot of points of collaboration and things that, I think that's one of the great things of these initiatives of ACI, right? You get to know other professors and other professionals that, otherwise you will not maybe have this conversation, or yes, but it will take more time, and that's really a great opportunity. And of course, we will see each other also in the ACI convention, because that's another thing that, it really makes a big difference for us to be able to meet each other, in some cases even twice a year, right? What do you think about that?
Yeah, no, absolutely. I think ACI has been really very, very, very important to my career. So I think the first ACI I went to was almost, my memory is not that good, but it was either 13 years ago or something like this. But because I spent 4 years in Europe, I could not really come regularly to the US for ACI. It becomes a little bit expensive. But actually, one of the things I really do want to thank ACI for is it helped me get my postdoc. So it was one of the ACI conventions. I think it was in Kansas City or something. So I actually met Jason Eidecker, who's at Oregon State, and then we started talking, and they had openings for postdocs at Oregon State, and I was like, fantastic! I don't have anything else, so I actually, worked through that. And I mean, if not for that convention, I probably would have a very different life at this point. So yeah, ACI did help me get my postdoc. I go to ACI very, very regularly. I don't think I've actually missed any in the last 7 years or something. I mean, obviously, it became a little mess with COVID and online and that, but it's something that I'm very involved in. I also make sure my students go to ACI. I think every ACI I've had at least one, but closer to 2 or 3 students go. I think this one it's maybe 4 or 5 students who are going, so it's going to be a nice team from UM. And I have to show off just a little bit because the current president, the 100th president of ACI, is actually from the University of Miami. So of course, Miami has a very strong ACI connection. But yeah, we go regularly. My students go regularly. For me, ACI is as important for the science as it is for the networking. And it's also very important to me that ACI is not 100% academia. I don't know the split. I'm guessing it's 50-50, something like this. But that's very important to me because it's a little difficult to just do things in a bit of a vacuum. So I really like talking to industry at ACI, kind of trying to understand, the bigger picture, because to a certain extent, I get very focused on small details on microstructure, things like that. I don't necessarily understand the big picture. So something like ACI is fantastic. I'm heavily involved in 231, 232, 240 membership committee, things like that. And I know for sure that my involvement in ACI is not going to go down. So
yeah, for me, I mean, there was many things. One of them was when I went to the ACI professor workshop. That really helped me because I met a lot of professors, spent several days there, and that will really help me a lot. Then, for example, one of my students got one of the ACI fellowships, and she's coming. She already went last convention, and also will go this one too, funded by the ACI, and that really helps because it's difficult to get the funding to bring the students to the program. Last time I think it was 4 students, well, 3 students and one postdoc to the convention. And also I met there also one of my former students, which was great because you meet again, and that was very special, and that's something that ACI can make for us. I am involved in the committees 555 and 1302, also in other ones, but these ones are the ones that I'm more involved. And what I really like about it is that everyone listen to each other. You are there and you are one more, even you're young or so. And I think what we can do, just getting together there and discussing everything, and start to all these new documents and be able to participate on that. That's a privilege. That's amazing, and that's something that I really like. And as you say, it's also a point of contact with industry and to start to talk about different perspectives. For example, with my research on nanomodification of the microstructure to make concrete to capture more CO2. And that conversation has really helped me to see also the point from the industry and find a different way to do it. So I really like these conversations and see all different points of view. And I say like, yeah, I know what you mean, and then now I will do it this way, and that works for you now too. So that's really something that is special, I think, for ACI. It's not a vacuum. It's not just only academics. It's not only industry. That in some conferences like that, right? It's just only industry, and we are just a few academics there. That also doesn't work so well. But this one has the perfect mix, and I really think that's something special. And I encourage everyone to attend. And new professor or even postdoc, it can go to the ACI professors workshop. I encourage you to go. That's a very good first step. Also, the ACI faculty network. There's a lot of resources if you are just starting on that.
So I'll put in one other plug for ACI and then I think we can stop. Yeah, everyone should, if you're interested and if you're able to go for the ACI conventions. This one is in Boston in about a month. I think it's going to be a fantastic event if you can be there. And one of the nicest things is that ACI student membership, oh, I don't remember if it's free or $5, but whatever, it's absolutely nothing. It's either free or yeah, $5. So if you're a student, you should be a member of ACI. You have absolutely no excuse.
Yeah, I agree. And it's very good for you and for your future. No matter what, if you want to go for academia or if you want a postdoc or if you want to go for industry, is perfect place.
Awesome.
Yeah.
All right.
So I think we are kind of on time. What do you think? I think we are right on time, so we should wrap up.
I think we should wrap up. Yeah.
Yeah. So, well, thanks again for joining us, and thanks to everyone for listening to this month's episode of Engineering Greatness. Join us each month as ACI brings together pairs of young professionals in the concrete industry to engage in intimate conversations about their lives and work. Be sure to subscribe to our podcast on Apple, Spotify, Google, or wherever you listen to your favorite podcast. And for more information about the American Concrete Institute, visit us online in concrete.org. We will see you next time.